So it's my first official lesson in my classroom, chapter 7, last 2 weeks. Let's make it happen. Okay, I'm going to zoom this in a little bit, and I want, even though I announced this in class, I want you to see it again. So we're going to do this week 8, which is this week, and then this will be week 9. You will be quizzed on week 8 on Monday, October 5th at 12. Because you have class at 12. So the people that are in here on Monday, which will be, I think, the D group, which are the normal Friday groups, you will just take it in the classroom, okay? And yes, you can still use Open Notes just like everybody else, okay? And then you're going to learn this information Tuesday, Wednesday, Thursday, and then Thursday you will take the last quiz that will cover this, okay? Yes, I know it's a lot, but I'm not giving a final, and I want this to be done by Thursday. So if you're the Thursday people, that's the C group, you'll be taking it then, okay? So let's get started with the lesson. So I'm assuming you're watching this after you already had the first lesson with me, so you kind of have an idea of what's going on. All right, so we're going to be finding the inverse. So if you're going to find the inverse, I want you to put it in exponential form, okay? So if you're going to put it in exponential form, it's a little bit backwards. So if it's easier for you and you want to do this, some people, it might make them feel safe, is to do this, because that's the way I taught you. That's fine. Or if you want to go like this, it's the same thing. But what does it mean? It means that 2 to the y equals x minus 1, okay? And this one's going to be a little bit different because you're cheating it a little bit. So now what you're going to do is you're going to switch the x and the y. And now solve for y, add 1. And I know it says y equals, so you're just going to have to keep writing y equals. You can't write y inverse. So y equals 2 to the x plus 1. That is the inverse, okay? So I want to show you now, in log is the inverse of exponential form. Exponential form is the inverse of log. So I want to show you, I did it on my cell phone so we could see it. So let me zoom in a little bit. So if you look, I graphed the original. And then I graphed the reflection line. And then I graphed the new ones. And if you see, the log and exponential, okay? They're a reflection of each other, and that should happen every single time, okay? Now, what does that also mean? That means if I was to do a table here on the first one, well, all of those are undefined because negative's undefined. If I have 2, 0 for the red, that means for the purple, I should have 0, 2. We'll look at that. Let's see, is it going to tell me the point? 0, 2. But remember, I can always go like this. I can make a table, and then it tells me 0, 2. All right? Let's do the next one. Again, for number 2, you might feel safe by putting the y over here. Now, notice the difference between this one and this one. In this one, the x minus 1 is in parentheses, so I could go straight to exponential form. The problem is, in this one, there's a negative 8. So I am not actually ready to go equals y. I'm going to have to go plus 8 plus 8. Of course, I pick a pen that doesn't work. Okay, we'll work on that. Let me pause it real quick and get a different one. Okay, I got a new pen, you can see. Now some of you go, I don't understand. Remember when I gave you these problems? And you would go, okay, it's time to square root. And I go, you have to get rid of the number with the squared. Then once you get rid of the number that's with the squared, then you could square root. So what does that mean? You need to just have the log. Once you just have the log, I'm going to move this over so you're left with y plus 8 equals log 2x. It's one term. Now you can change it to exponential. So in a sense now, this is what your parenthesis is, okay? Now some of you might feel safe putting it on the other side. So I will do that. Now I'm going to put it in exponential form. So it's going to be 2 to the y plus 8 equals x. What did I say to do now? Switch the x and the y. and then solve for y. Oh, cool, it's already solved for. I am done. Okay, let's look at this one. Am I ready to put this in exponential form? Yep, it's just one group. Some of us feel safe by going like this. Put it in exponential. So that would be 2 to the y equals negative 2x. Switch the x and the y. So maybe I should put here, step 1, put it in exponential form. Let me zoom out a little bit. And then step 2, switch the x and the y. And then step 3 is solve for y. Okay, you'll make it look nicer, but you get the game. Okay. So let me go back and zoom in. Okay. Now what do I have to do? Solve for y. So what do I do? Divide by negative 2. Divide by negative 2. Now y equals 2 to the x over negative 2. It's not pretty, but you get the game. Now, how could I prove if I'm correct or incorrect? Graph this in Desmos, graph this in Desmos. If I can't tell if they look like they're a reflection of each other, then I can find an x value and a y value and make sure they're switched. Okay? All right, number 7. How is number 7 different than the other ones? Well, if you look here, all of these, let me zoom out, are in log form, so you turned it to exponential form. So that means now, if these are in exponential form, what do I need to do? Put them in log form. You don't have to be perfect at this yet, okay? I realized I probably should have done another lesson first to make it a little bit easier. Okay, so hold on. So, what's the first thing I do? Add 6. Remember how I had to have the log be by itself? I need to have this by itself. So now I have y plus 6 equals 5 to the x. Okay? And now I'm ready to put it in exponential form. But what do I have to do? Switch, where are we? Switch the x and the y. So this will turn into an x, and this will turn into a y. Okay? Now, this is a parenthesis. Okay? And I'm going to put it in exponential form. Some of us feel safe putting the x plus 6 over here to now go like this. And I would go log. This is my base. My base is small. Next is x plus 6, and then equals y. These need to be the exact same size, and this needs to be really small. I want you to see, now some of you go, I don't know, Ms. Rifkin, I'm not convinced. What could I do? I could graph this and this, put it in Desmos, blah, blah, blah. But here's what I want you to see. Let me zoom out a little bit. See how these two look very similar? And then look at this. These two look really similar. So I might not be making it up. All right, let's try number 9. So what am I going to do in number 9 first? I cannot change it to exponential form until I move that 8 over. So let me do that. And then I'm left with y minus 8 equals 2 to the x. So if the first step was to change the form, the second step is to what? Switch the x and the y. So now I'm going to make this an x. And I'm going to make this a y. And some of us feel safe to put this over here. If you're fine, you don't need it, then don't do it. Okay? Then this, oops, x minus 8. I'm doing awesome. And I get log, this is my base. This is my answer. This is my exponent. And now I'm done. Okay? Next thing I'm going to ask you to do is I'm going to ask you to graph these things. Now, yeah, I could just copy it off Desmos, but I don't want to copy off Desmos. I want to do this myself. So, an obvious number for me to pick is 0. And I need to remember, let me zoom out, that any number to the 0 power equals 1. Any number to the 0 power equals 1. And some of you go, what? Okay, let me give you an example. If I have 3 cubed, I bet you agree that's 27. 3 squared is 9. 3 to the first is 3. What's the pattern happening every single time? Divide by 3. So technically, I don't even have to figure it out. As long as I follow my pattern, 3 divided by 3 is 1. And hey, anything to the 0 power is 1. And some of you go, okay, well then if I'm following the pattern 3, 2, 1, 0, negative 1, what is 1 divided by 3? 1 divided by 3 is 1/3. Now remember, when you have a negative exponent, you move it to the bottom, it turns positive. 1 over 3 to the first is 1/3. So 3 to the negative 2. That means now I'm going 1/3 divided by 3. So if I go 1/3 divided by 3, that's 1/3 divided by 1/3, which is 1/9. Let's see if this makes sense. When I have a negative exponent, I move it to the bottom, it turns positive. Hey, 1 over 3 squared is 1 over 9. So there are patterns. It wasn't just made up because they were bored on a Tuesday. Okay, so we know anything to the 0 power is 1 times 2 is 2. Now I'll try 1. And actually, I don't want to try 1. The reason I don't want to try 1 is because 1 will give me a fraction. Okay, well, I'll do it just for fun. I'll put it here, okay? And I can do 1, but if I go 1/3 to the first power, that's 1/3 times 2 is 2/3. I'm not going to be very good at graphing 2/3. But if I do negative 1, 1/3 to the negative 1, flip it, 3 over 1 to the first power, which is just 3 to the first, which is 3. And then I'll go negative 2. Oh, I'm sorry, is 3 times 2, forgot to multiply, is 6. Okay? Then if I go 1/3 to the negative 2, that really means 3 over 1 squared, which is 3 squared, which is 9, times 2 is 18. Interesting. Anybody see the pattern? Times 3, times 3. And some of you go, but no, the pattern is times 1/3. Yeah, that's when the numbers get bigger and bigger. But these numbers are getting smaller and smaller. So now I'm going to graph it. 0, 2, negative 1, 6, negative 2, 18. And you're going to learn this is called exponential decay because my numbers are getting smaller and smaller. They never approach 0. You will never get zeros. You will never have negatives in your y. You can have negatives for your x, and you can have positives. So what does that mean, the domain for this? Negative infinity to positive infinity. But y has got to be greater than 0 for the range, or 0, positive infinity. We'll get into that more, okay? Let's go do one more. So I'm going to do x, y. What number am I going to start with? 0. Anything to the 0 power, 1 times 4, 4. Now, do I want to do negatives this time or just do positives? Well, it's a whole number, so I'll do positives. 2 to the first is 2 times 4 is 8. 2 squared is 4 times 4 is 16. Hey, what's the pattern? Times 2 times 2. And I'm going a little bit fast because it's about to run out of time. 0, 4, 1, 8, 2, 16. Never quite hit 0. Okay, so what does that mean the domain is? All real numbers. What does it mean the range is? Y is greater than 0. Okay, this will be, oh, by the way, let me point out, what problems I don't do will be homework. So all of this, homework. You need to show work. All of this, homework. Okay, and then this one I'll do on the next video.